Hello and welcome again to this bonus video series. Today I am going to prove the product rule for the curls. Okay, so the curl, we take the curl of a vector, so we have to include the vector quantity over here. So one way we can make the vector like this, the other way taking the cross product of two vector. Okay, and f is a scalar quantity, but of course it is a scalar, but it itself is not a constant, right? So it itself may be a function of, let's say, x, y and z, so r vector, right? So the first property, so I'm writing over here the product rules for curl. Now del cross f of a, and what it is going to equal to, well, it is going to be f of del cross a minus a cross gradient of r. We have to prove this. Okay, so we will take this LHS. Now f of a is going to be f of ax, x cap, f of ay, y cap, plus f of az, z cap. Del cross f of a is going to be x cap, y cap and z cap. Now del x, del y, you should remember this symbol del x, which is del y, del x. Okay, del y and del z, and here we will write f of ax, f of ay, f of az. Okay, so for the x component we are going to have del y of f of az minus del z of f of ay. Okay, for the y component, okay, so I am just adjusting this minus sign that comes at the in the front of this y cap. So for that we will take this and that of that, so we'll take the opposite of that. So del of z f of ax minus del of x f of az. Okay, the third term will be del of x f of ay minus del of y f of ax. So we have three terms: first one, second one and third one. We are going to expand all of the three terms. Okay, so we have already okay, right. So it is gonna be del of y f of az minus del of z f of ay. What it is going to be? Well, it is going to be del of y a of z plus a of z del y of f minus minus f of del of z of ay minus a of y del of z of f. Similarly, we have second term del of z f of ax minus del of x f of az. F times del of z ax plus a of x del of z of f minus f type del of x a of z minus a of z del of x times f. del of x f of ay. Okay, so this is a, right, minus del of y f of a of x, right. So we again use the product rules, right. F means del of x ay plus a of y del of x f minus f del of y ax minus a of x del of y f. Okay, so these 4 12 terms are the I mean we'll get this 12 term after expanding the LHS, right. Now we will take yes, so what we can do now, and yes, one more thing, that we have this x cap for all this term, y cap for all this term, and z cap for all this term, right. What we have to do, we have to write this 12 terms, these 12 terms into this and this term. Okay, so how we are gonna do this? Okay, so if we name it, it is the first term, this is the second term. So first of all we will try to write this first term. I mean we will rearrange these terms to write the first term, which is f times del cross a. Okay, so what we have to do, we have to write the del cross a first of all. Okay, so what is this, how can we do this? Well, we can do this by rearranging these terms, right. So we'll take all the terms which have f as a factor. Okay, these are the terms which have f as a coefficient or a factor, right. So we have f will be out. Okay, and then we are gonna have del y az minus del z ay and x cap. Okay, so we have taken these two terms, right. Then again, yeah, again for the minus sign, and minus sign will be there, we have taken the minus sign. Okay, so in the second time we are taking this and this term, right, and we are taking the minus sign out. So we will write this term del x az minus del z ax, and y cap will be there. And then for yeah, we're gonna have these two terms, right, plus del x ay minus del y ax and z cap. F times del, then we have, this is going to be del cross a. So we have obtained the first term from these equation. Now we will going to do obtain the second term from these equation, right. So these are the remaining term. Okay, this and these are the remaining term. So let me obtain the second term from this. So what is second term? Let me write it first. The second term is del cross gradient of f. Okay, so yeah, so this red marked terms are yeah, so all the okay, so